Hello everyone, welcome back to the channel. I am Nikhil Kumar. Today I have something super excited to show you. Imagine being able to predict SLA breaches before they actually happen, giving your team a chance to act before users are even affected. That's exactly what we are building in this series. I have developed a custom breach predictor model that integrates with Prometheus and Alertmanager to analyze real-time alert data and forecast SLA violation. In this series, we are going to containerize and deploy that model using Docker and then simulate an alert using Postman to see it in the action. And in the upcoming video, we will connect it to the ITSM and Microsoft Teams for real-time escalation. So if you are into DevOps and AI or automation, this series is totally for you. So let's dive in. Why SLA breach prediction is a game changer. SLA breaches are costly, both financially and in terms of customer trust. Traditional monitoring systems are reactive. They tell you something broken after the fact. But if we could predict it before the impact, we can reduce cost, avoid financial penalties, and maintain customer trust by preventing SLA breaches. Proactive monitoring. It helps us to move from reactive to proactive monitoring, addressing issues before they impact service levels. Improved resource allocation. It helps us to optimize resource allocation by identifying potential problems and addressing them efficiently. At last, enhanced performance ensure consistent service delivery and maintains a high level of system performance. This is where our AI-driven predictor steps in. It takes incoming alerts, processes patterns, and assigns a breach probability score, essentially forecasting the likelihood of an SLA violation. Let me show you how this system fits together. In this architecture diagram, Prometheus craves system metrics using the node exporter, and then the alert manager detects the threshold breaches and triggers the alert. So it sends a request to the FastAPI, and the FastAPI forwards its request to the endpoint that is a predict URL. On the basis of the data, breach predictor model ingests this alert data and uses a trained AI model to compute breach probability. If the score is high, it escalates the issue via ITSM or the Microsoft Teams. This turns firefighting into foresight, giving ops team a head start before things spiral. Now let's see how this model actually works. Right now we are inside our project directory. Let me show you the files that power the model. As you can see, in this particular directory, I have already stored the vectorized.py file, which is our TF-IDF vectorizer and the model file. And we already have a alert data.csv, which is having the alert data. Along with that, I have the image builder directory, which is used to containerize this particular application. Let's run the model training and vectorization script. So let me run the vectorized.py. So it will train the model and it will generate the breach model.joblib and the tf-idf vectorizer.joblib files, which will be used to containerize our app, and it will also generate the output of the alert data. As you can see, our model got trained and we get our model accuracy up to 71%. Our prediction are saved to the output prediction.csv, and also model got saved to the breach model.joblib, and our vectorizer also got saved to tf-idf vectorize.joblib, and we can see all three files got generated. Now let's jump into a Docker build folder and containerize the app. In this particular directory, we already have a API logic, requirement.txt, and the Docker file to build an image. But we need to move our saved model as well as the vectorizer joblib file. So let me move that as well. So I have moved both the files here. Here I am using a minimal Python image to keep everything lightweight. So let's build a Docker image. Docker build -t breach -API. Let me give the dot notation here because our Docker file exists in the current working directory. Now it's building an image. Now our image got created. Let's verify it using the Docker images command, and we can see that image got built. Now we can run the container and expose it on the port number 8000. To do that, let's run the docker run command, docker run -d-p 8000 and 8000, and the image name, that is breach-api. Container got created. Let's verify that. Our AI model is now running inside the Docker on port number 8000. Now let's simulate a critical alert to test if the model works as expected. Let me open the Postman here, and this is our URL, and this is the endpoint for the same, that is a predict. Now let's simulate a critical alert to test if the model works as expected. So let me enter the payload here and hit the send. As we can see, our model have predicted the probability, that is 83%. In the real world use cases, this will automatically escalate to your IT team or the service desk. So now we have deployed the model and tested it successfully. But that's just a beginning. In our upcoming videos, we are going to do the integration with the ITSM tool like ServiceNow or Jira. We will also add real-time alerts in Microsoft Teams or Slack. And we are also going to do the fine-tuning of the model with more accurate prediction with smarter models. And at last, we are going to deploy it on the Kubernetes for production scale. By the end of this journey, you will have a production-ready, AI-powered SLA breach prediction system that you can deploy in your environment. I hope you are excited as I am excited about this project. If you found this useful, drop a like, subscribe, and hit that bell so you don't miss what's coming up next. Comment below if you got question or suggestion. I would love to hear what else you would like to see. Thanks for watching. See you in the next one where we will take this setup to the next level.